Place your bet.
I'm all in.
You sure about this?
Yeah.
Flip your cards. A straight flush. Sorry.
I just can't stop. Can't stop winning. It's too easy. Too easy.
The winner is Aria.
That's right. Who's the winner? Who's the winner?
Hey man, how did you get so good?
I learned from one of the best. His name's the teacher.
Where can I find him?
It's kind of hard to find. Might be able to hook you up though. He taught me some of the best ways by beating the odds by using math and probability. It's crazy. I'll see what I can do. Might be able to help you out there.
I heard you were coming. The prodigy Arya told me that you needed some help. So how can I help you?
I need to get my money back.
Well, I have a small fee, and I will be able to help you. It's just $1. Thank you. I'll put this with the rest of my money. As you can see, I'm very rich. Okay. So, you lost all your money playing poker, right?
Yeah.
Easiest way to recover your money? These two babies right here. So, first, inclusive events. They're described in the formula as probability of part A plus the probability of event B minus the probability of event A and B. And this is because inclusive events can occur at the exact same time. And that is why using 2 die is a perfect way to gain your money back. Now let's look at an example. If the question is, what is the probability of rolling an odd number or a 3? The probability of event A, which can be stated as the odd number, in a 6-sided dice is 3 out of 6. Plus the probability of rolling a 3 on a 6-sided dice is 1 out of 6. But because 3 is an odd number, you have to subtract out that value. So the probability of A and B is 1 out of 6. This mutually exclusive involves events that cannot happen at the same time. Formula as the probability of part A plus the probability of part B. They use the word or, meaning that only one of them can occur at a single time. So let's take the example of the 2 die again. In a 6-sided die, if the question is rolling a 1 or rolling a 6, only one of those can occur at the exact same time. So you take the probability of the first event, rolling a 1, and on a 6-sided die, that is 1 out of 6. Plus the probability of rolling a 6 on a 6-sided die is also 1 out of 6. This just gives you a probability of 2 out of 6. However, that is only 33%. So when gambling, you must take a look at inclusive events rather than mutually exclusive events. Now I have to go take care of some unfinished business. I'm going to hand it off to my assistant, Eyes.
So now we get on to conditional probability that relates two dependent events together. And this will help you in poker and other card games. So to explain this, I'll first show you the formula. Probability of B, which is the second event, given that A happens, which is the first event. So the formula is the probability of A and B happening together over the probability of A happening. So you figure out probability of B given that A happens. So for this example, I'll look at two events: probability of drawing a heart and probability of drawing a face card. Probability of drawing a heart is, as you know, 13 or 52. The probability of drawing a face card is 12 or 52, and rolling them to drawing them together is 3 or 52. So for probability of for them happening together is 3 or 52. and probability of A happening is
13.
12 over 15. No, 12. What are you,
Oh.
So, and then you can just plug this into your calculator and figure out the answer. So now we get on to independent events. Usually in poker and other card games, you don't use these, but if you come across a card game that you put the card bag after drawing it, you can use this to understand what's going on. So this is basically proving if two events are independent. For example, probability of drawing an odd after an even is equal to probability of drawing an odd. But this only applies if the card after drawing is put back.
So, how do you do?
Now the only thing he has to do is prove his skills. He has to play you.
Let's take it to the casino.
Last two cards. Ace. And a king. Alright, flip your cards, boys. 2 and 3. I'm sorry, Jay.
Yes.
I guess there's a new prodigy in town, huh?